So this is what I like to call an example. It's a joke. Example. So I want to find this derivative using a limit and double check with the quotient rule. And I'm going to ask you to do one just like it on your test, right? So let's say f of x is x minus 5 over 2 minus x. So we want to find f prime using a limit and double check with the quotient rule. Now we just learned the quotient rule, but it's easy. And you have your formula sheet. So there should be no problem for you to do it. Is there anything say that I can't do the quotient rule first? Does anything on this say I can't do the quotient rule first? No, I can do the quotient rule first. And then I can also double check it on Desmos before I go do that horrible long limit, right? Yes? You with me? So you want to be smart about this, how you're going to do this, right? This is two problems. So if I can do this quotient rule and check it in 2 minutes, now I have 15 minutes to do the limit problem, right? You got to think about this stuff, right? You got to be careful about wasting time. You got to be careful about spending 40 minutes on one problem and then ending up with 3 problems blank, right? So you want to really think about how you're taking the test. So let's do our quotient rule first. Upstairs function is x minus 5. Derivative of that is 1. Nice. Downstairs function is 2 minus x. Derivative is negative 1. Yeah, that's okay. And then we have a downstairs of 2 minus x, and we're going to square that for our quotient rule. So f prime is going to be 2 minus x plus 1 times x minus 5. And it's a little, I'm doing it a little bit like the way I wouldn't want you to do it. I'm doing things in my head, right? But I do know I can check this for sure and know if I'm right on Desmos, and then I'll come back and double check. I'll say, all right, I'll do it again, but I won't skip anything, right? But upstairs now I have what? 2 minus x plus x minus 5 over 2 minus x quantity squared. So it looks like my final answer is what? Negative 3 over 2 minus x quantity squared. And there's my f prime. Not bad, right? Easy, yes? Yes, question. Do it. Question. Yeah, 2, positive 2, negative 5, right? Yep. No problem. Now, we want the same thing using a limit. Now, I'm going to double check it before, right? Yes, Abigail? Sure. Don't let me go too fast. Say it again? Yes. It is, but there's a negative 1 there. So if I'm subtracting that negative 1, it's going to be plus 1. Yep. And that's what I was saying. I'm doing that in my head. That could be dangerous, right? And like I have things circled on your quizzes where you made a sign error or something, right? And a lot of times it's because you just skipped a step or you did something in your head. And I don't know if you know it's in this one, but this one's dangerous, right? I don't know about your own, but do it. Yes, sir. Yeah, right there, good? Yes, Calista. Yeah, so here, I won't skip the step, okay? Because I can tell it's bothering several students, and that's fine. So it's the numerator is 1 times 2 minus x minus this product, right? Minus the negative 1 times x minus 5. So what I did was, in my head, dangerous, I changed that right away to the plus 1 out there. I could have distributed the first negative, and then I would have to distribute another negative. So I didn't bother. I just changed it to positive on the outside and took off the parenthesis. All right, now the derivative using a limit. If you can't get this, that means you can't get it on the first test. That's probably 20 points off the first test. And you won't get it on the final, right? What I like to do is for the final exam, I like to take all the problems students had trouble with and collect them and put them on the final. So you can finally show me, okay, you couldn't do it on the quiz, you couldn't do it on the test, now you can finally do it on the final, and then if you pass the final, you pass the class. I don't care about the other grades. If you pass the final, you're good. You're probably screwed in Calc 2, but at least you don't have to take this one again, right? So I'm saying these things don't go away. You can't ignore them. You can't just avoid doing them. You have to be able to do every problem in the class. Why? Because if you can't do Calc 2. I'm telling you, I know where you're going. I went through it myself. Okay, I went through it myself. I struggled. And I've been teaching this for 20 years, right? So I know if you can get these things, you can succeed. But you can't avoid it. You can't ignore it. All right, here we go. F prime of x. A lot of notation issues that I will take points off on the test. So watch your notation. If you're confused about it, ask me. Yes, do it. Yeah, you got to go back to those lectures. This is chapter 3 stuff, but we have a product rule, and we have a quotient rule, and basically they're the same little loop, I call them. This one is this way. This one is this way. Yeah. So product rule is fg prime plus gf prime. Quotient rule is gf prime minus fg prime all over g squared. So that's all in those last 2 lectures. We did it twice. Okay. I'm putting this quotient rule on the test like we just did. Yeah. But you got 4 days. Okay, here we go. We're doing a limit as h goes to 0 of x plus h minus 5 over 2 minus x plus h, right? And notice I'm putting in empty parens here. These are not so much needed on this one, on the upstairs, but on the downstairs, notice I'm going to have to distribute what? The negative, yes. Minus the original function, all divided by h. And I'm saying that's the limit as h goes to 0 of star, period, end of sentence. Right? Now I'm using that star just to get my replacement function. And when I'm doing that, I see no problem with me getting rid of those parentheses while I transfer it. But if you're having trouble with it, don't do it. Don't skip steps. I want to wrap every multi-term numerator or denominator in parentheses. And then multiply by an LCD of 2 minus x times 2 minus x minus h all over itself. How is everybody here? Don't let me go too fast. I want you staying with me. Ethan's not here. Mawad's not here. Oh, sorry. Gotcha. Did I give you a quiz? David's not here. Michael's not here. Laura's not here. Laura's here. Sorry. Oh yes, we already talked. So I'm out of it. Sorry. Laura is here. How we doing here? We good? Why is that the LCD? Because my thought is I'm looking at only interior denominators. So I see. I'm not considering H. H is the denominator in the original problem, but I only want interior denominators. So this one's a denominator, this one's a denominator, this one's a denominator. Multiply them together, and that's not necessarily an LCD. Like on the quiz I returned, you could have had 8x cubed as your LCD, but the better answer would have been 4x squared. That's the lowest. I'm going to distribute in purple. I'm going to keep my original in black. So my original in black, I'm going to distribute in purple, or whatever color this is. Fuchsia, I don't know. I'm really trying to emphasize, go slow. You know, I mean, I'm not going so slow, but I'm doing things that are real safe so I don't make mistakes, right? And now my favorite part, the cancellation. And rewrite. How are we doing? David, Michael, and Ethan. 2, 4, 6, 8, 10, 12, 14, 16, 18, yes. Okay, so now we're distributing, and again, you know, you don't have to, you're not watching me distribute this. This is 8th, 9th grade or whatever, some of you 7th grade. So you don't have to watch me distribute, just distribute, right? So I'm just writing, you're writing. You're not copying me, you're actually doing the distributing. How are we doing there? We okay? It's kind of, look, it's nice to know I have an answer already. In fact, I have an answer already that I checked on Desmos, right? So I'm really happy to see that I'm going to get that -3 over here, right? I already see that part. It's coming. So we finally get our replacement function, which I called star, of -3 over 2 minus x that quantity times 2 minus x minus h, right? And that's my replacement function, period, right? That was one sentence. And it included a bunch of things that we are kind of understanding. If you remember high school geometry, when you had to say angle A is congruent to angle B because of CP, CPC. Do you remember doing that? Justifying your step, right? And I said this function is equal to this function because all I did was multiply by 1, but I didn't say any of that, right? Okay, this function is now equal to this function because I'm distributing. And then I'm combining my terms, but I'm not justifying that anymore. We know you are past that. So now I'm ready to write f prime of x is equal to the limit as h goes to 0 of star. I don't feel like writing that again. It's right above my line here. And what am I going to do? I'm going to plug in h as 0. Kind of a waste of time. Like Dogum right now he knows that h is going to go away, so he doesn't even bother writing it, right? But then he sees that he has 2 minus x, that product with itself, so we know that's 2 minus x quantity squared. To heck, 20 points on the test, done. 20 points for the quotient rule, 10 points for the quotient rule, 10 points for the limit.
So like if a question has 2 parts, then we still count it as 2 separate.
So I think my first 3 questions are 2 parts each, so there's 6 of them. That's 60 points. Nice. I think we're good here, right? Let's do maybe one more product rule, one more quotient rule, right? And then we can do our trig. We're doing trig derivatives today. So easy. And we're going to add them. We're going to add them to our formula sheet, right? I'm collecting formula sheets. Sometimes I'll see something weird on the test, and I won't be able to say, well, how did they do that? But if I look at your formula sheet and I could see, oh, right, I might see that you have some shortcut from the book written somewhere. So make sure they're nice and neat and ready. Make sure they're ready. Anything you want, front and back. Anything you want. Worked out problems, step by step, trig identities, unit circle, all the derivative shortcuts, tangent line, right? Definition of a limit, a derivative using a limit, all of that. Okay, let's do a quotient rule. Let's see. One of my favorites here is what? If f of x is x squared plus 1 over x squared minus 1. Let's get the derivative here, and let's do a tangent line. What's my domain here? What is it? Plus and minus 1, yeah? Plus and minus 1? Everything but plus or minus 1, right? If I put either of those in the downstairs, I'm dividing by 0, right? One of the things I always want you to do is I want you to get me a picture of the graph. If you don't know what it looks like, use Desmos. Use your calculator, either one. So I'm going to Desmos. Oh my God, why is it so slow? All right, f of x. When I'm on Desmos, you're on Desmos, right? X squared plus 1 all divided by x squared minus 1. So there it is, and you can clearly see a vertical asymptote, right? Vertical asymptote says plus or minus 1. Yes, you with me there? And what's my horizontal asymptote? What's this behave like in the long run? X squared over x squared, right? The mother function over the mother function. X squared over x squared is 1. So the horizontal asymptote is 1. You see it? We learned that in pre-calculus. We also did it with an infinite limit using L'Hopital's rule, right? So let's get our, maybe a tangent line at 2 looks pretty good, right? And so what's nice about Desmos is I can say, if I use this function notation, I can just say 2 comma f of 2 for my point, right? And that will give me the point. But of course, I want to figure out that coordinate as well. So I need the y coordinate, I need the derivative, I need the slope, I need the tangent line, right? So we said x is 2. I picked anything in the domain, and that's what I'm going to do on the exam. I'm just going to pick something like for the trig tangent line I'm going to put on there, I'm going to say minus 3 pi over 4 or whatever, right? So we need the y value, that's f of 2. That's what, 4 plus 1 over 4 minus 1. So 5/3. Everyone okay there? We need our derivative. So I'll ask you to race me on this one. Let's do our quotient rule. Now, on this one, you can decide, you certainly could decide to distribute this out. But when I look at it, what do I see I can factor right away? When I look at that numerator, what do you see you can factor? The 2x, the 2x, right? But on this, I mean, I don't care if you factor it or distribute it out, but I'm saying these little things I'm telling you to do will save you time. It's nice that I see this thing being negative, right? I see my derivative being negative when I put in a positive 2, right? Because when I look at the graph and I picture that slope there at that point, you definitely could see a negative slope happening, right? How are we doing? Yeah.
So when you factor it out,
Yep, so I factored out the 2x.
what is the, why is it X?
So what's left over is in blue, right? There's that blue piece, and the opposite of this yellow right? The opposite of the yellow, right?
Yeah.
And again, I don't care if you skip steps as long as you don't make a mistake. If you're making mistakes, don't skip steps. It will take you more time to do it really quick and make mistakes and then have to do it over than if you go slow and methodical the first time, right? But hopefully you're learning where all those mistakes happen when you're doing homework. And then when you go to take the test, it should be fixed by then. If you're not doing homework, if you're not practicing the 5 to 10 hours a week I'm asking for, maybe 15, you're in trouble. You have to practice, you have to make mistakes, you have to get it fixed. How'd we do? Anyone get there? Nice. Good. Slope is f prime at 2. So negative 8 over, what, 4 minus 1 quantity squared. So negative 8 over 9. Yeah? We got slope. Anybody else got a slope? Charlotte, Kelvin? Anybody else? Nice. Max? Calissa, yeah? Nice. Daniel? Yeah? Awad, yeah? You got it? Good. Anybody not get it that wants help? Okay, tangent line. Y minus, what was my y value again? 5/3? Equals negative 8/9 times the quantity of x minus 2. Is everybody clear on that, where we're getting that from? What's a nice thing to do is check it now before you go do your LCD and everything. Check it now and see if it works, right? Yeah, Desmos is pretty good in that. I still want a prettier answer. Pretty is in quotes, of course. But Desmos will take this line now. So y minus 5/3 equals negative 8/9 times the quantity of x minus 2. So it's nice to know before I do more algebra that I got it right. And then, of course, I want to simplify. I want to get up y equals mx plus b. And then I want to check it again, make sure I didn't do something wrong, right? Like you couldn't do that on the 89s, right? They won't allow you to put that in. TI 83s, I mean 84s. $16 and 15 is 31, right? I had a professor in college when I transferred. It was my first class transfer. It was bridge to abstract mathematics. It was about proving things, and you could get a negative score on his test if you got things wrong, and it was worth 4 points. He would take off 8. So if you left it blank, you only lost 4. If you put in the wrong answer, you lost double. I think my first test score was like 22. I'll never forget him.
Luke said if you got some questions right, but then you got something wrong, then you would get like
You could, yeah, exactly. So the whole test was worth 100. If you answered everything and got everything wrong, you got a score of negative 200. Yeah, but he's trying to teach us to not put down nonsense. If you don't know what you're doing, if you didn't practice, you didn't know what you were doing. I mean, I would never do that, but it taught me something. I go ask him for help in a problem, and then I'd say, I get it. I'd be lying. And then the very next test, that problem, exact problem, would be on the test. And as I'm walking out the room, he says, I put that one on for you. I'm like, oh, God. This guy. All right. I think we're good, right? We can move on. Yeah? Nice. Here we go. Section 3.3. Our next section is chain rule. I need you caught up. Okay? So I need you to have the product rule, quotient rule, and these trig derivatives down for when I start doing the chain rule on Monday. Okay? So after today, there's no more new material, but today's material is not on the test. Okay? Today's material is not on the test, but you probably should still put these on your formula sheet because you're kind of building it up as we go. So we're going to talk about 3.3 trig derivatives. So we already know that if y equals sine of x, y prime is cos of x. And if y equals cos of x, y prime is negative sine of x. And I gave you that alphabet wheel, right? A, B, C, D, M, N, O, P, Q, R, S. So if I'm following that wheel clockwise, you can see if I go from sine to cosine, I do not pass the negative. So derivative of sine is positive cosine. If I go from cosine to sine, I pass the negative. So derivative of cosine is negative sine. What's that? Negative. Negative, yep. So cosine to sine, I need a negative. Sine to cosine, I don't. Right, and it's A, B, C, D, right? Just go doing the alphabet around the wheel. Yeah. Let's prove the first one. So we'll say f of x is sine of x. If f of x is sine of x, show f prime of x is cos of x. And of course, we're going to do that with a limit. It's the limit as h goes to 0 of sine of what? Very good, class. X plus h minus sine of x all over h. For this one, we needed our trig identity, right? So we want our trig identities on our formula sheet. Double angle, half angle, sum and difference formulas, sine, cosine, and tangent, okay? Make sure you put all those on there. So we know from pre-cal, sine of alpha plus or minus beta is sine alpha cos beta plus or minus sine beta cos alpha. From pre-cal, trig identity. Yes, you should have them all on your formula sheet. So sine of alpha plus beta, cos of alpha plus beta, tangent of alpha plus beta. Of course, the tangent of alpha plus beta, you can get away with sine of alpha plus beta over cos of alpha plus beta, right? So we're working on star here. And it looks like, so let me not skip this step. Let me first write it over because I'm sure you're panicking right now about the trig identities. So, but I'm going to use in blue here, I'm going to use my identity and get what? Do you see it? Sine x cos h, right? Yep, plus sine h cos x. Still minus a sine x, and still all over h. Is everybody okay there? Dogum's okay. Anybody else okay? Yep. Thank you. Thank you. 3, 4, 4.5, 5, 6. Nice. The thing is, when I tell you, if you look at all my chapter 2 tests, you'll see the one trig identity I've put on there a bunch of times. I didn't teach that section to you yet today, this semester, and I'm not going to. It was things related to the squeeze theorem or things related to the limit of sine x over x as x goes to 0, right? And I went through all the tests and I told you, don't do that one, don't do that one, don't do that one, right? But there is another place where a trig identity comes into play. Make sure you look at all of those, okay? So what do you see I can do here? It looks like I can factor out a sine x from here, right? You with me there? So I'm going to do a divide and conquer here. Sine x cos of h minus sine x all over h plus sine h cos x over h. Yeah, we okay there? Divide and conquer, right? I see the pieces that I could possibly factor, and I think something might happen with those. So I can factor out here my sine x, and I will get cosine of h minus 1 over h. And here I'm going to keep my sine h over h times my cosine. Why? Because look at what happens on each of these pieces. Look at what happens on each of these pieces when I let h go to 0. What happens? What happens here when I let h go to 0? So I get 0 divided by, right? So that we know we can handle with what? L'Hopital. And when I plug in cosine 0, I get 1. 1 minus 1 over 0. 0 over 0. I can handle that with L'Hopital. Right? So this is my replacement function star. I'm ready to go back to the limit now. It's the limit as h goes to 0 of star. Right? So what do I get? I get sine of x times the limit as h goes to 0 of cos of h minus 1 over h. Why didn't I apply the limit to sine of x? It's a yeah, there's no h in it, right? H going to 0 doesn't change it. So it might as well be a constant. And then on the other one, I've got plus cosine of x times the limit as h goes to 0 of sine h over h. And again, why didn't I apply the limit as h goes to 0 for cos of x? Because there's no h in it. Each of these I'm going to do with a little hop. So I get sine of x times the limit of what? What's the derivative of cosine? Negative sine of h, right? Over 1, but who cares, right? Plus cosine of x times the limit of what? What's the derivative of sine? Yep. Over 1, but who cares, right? Yes, we're okay? So what happens to sine of 0 now? When I let this limit happen, what happens to sine of 0? 0. So sine of x times 0 plus cos of x times what? What's cos of 0? So I just get cos of x. Yeah, where are you talking about? Yeah. So on that line 4, well, better yet, line 5, right? From the cos of h, derivative of cos of h is negative sign. Derivative of the negative 1 is 0, gone. And derivative of h underneath is 1. There's a little 1 there. And now I let that limit, I let h go to 0, sine of 0 is 0. No, this would never. If I gave an extra credit question, it would be prove that the derivative of cosine is negative sine using a limit. Do you hear that?
Yeah.
If I were to put an extra credit on this test, I would put this problem on, but I'd say prove that the derivative of cosine is negative sine using a limit. All right, back to our shortcut list, yes? So if y equals sine of x, y prime, you don't have to write this again, right? Y prime is cos of x. If y equals cos of x, y prime is negative sine of x. If y equals the tangent of x, y prime is secant squared x. Proof. What's one of our identities for tan? Tan of x. Sine of x over cos of x. And that looks like what rule? Quotient rule. Upstairs function is sine of x. Derivative of sine is cos. Downstairs function is cos of x. Derivative of cos of x is negative sine of x. And because it's a quotient rule, we're interested in cosine squared of x. We're interested in that downstairs squared. David and Ethan, not here, right? Everybody else, good. So y prime is cos squared x plus what? A negative minus sine squared, right? So positive sine squared, right? All over cos squared. But cos squared plus sine squared we know is 1, right? And so 1 over cos is secant, so secant squared x. You should know all the Pythagorean identities for the trigs, right? Double angle, half angle, sum and difference. Pythagorean, I think that's it. That's about 12, 15 identities. If y equals secant of x, y prime equals secant x tan x. Again, provable by quotient rule, right? Because secant is really 1 over cosine. If y equals cotan of x, y prime is negative cosecant squared x. And if y equals cosecant of x, y prime is negative cosecant x cotan x. So there's six identities that we want, trig identities that we want on our formula sheet. You will not need them for Friday. For Friday's derivative with the trig, with the tangent line, I'm giving you the function, giving you the derivative, giving you the x value. How are we doing? We okay? Yes? No? We okay? So these last three I just gave you, you should do on your own using the quotient rule. Okay? Yeah, Daniel?
So there's one on the bottom, that's a negative cosecant.
Yeah, negative cosecant x cotangent x. So do those last three using quotient rule on your own, okay? Let's go to the book. Let's do a couple problems from the book. No homework due Monday. I need you caught up for the chain rule. I need you to know, do problems in 3-2 and 3-3 to be ready for the chain rule. Autumn, question? So these problems are all easy. So I'm going to give you suggested problems in 3-1, 3-2, and 3-3, right? And of course, you've got the odd solutions, so any of the odd problems, right? Man, I've gotten like a bunch of emails about people being sick, so just be careful, be conscious, right? And try and eat right, try and sleep well, exercise, yes? So in 3-1, I probably said this already, but I just want to say it again, okay? In 3-1, I probably like up to 77. They talk about a normal line sometimes. I mean, easier on yourself up to 40, 43. But they talk about the tangent line and the normal line. The tangent line, right? You can see the tangent line on the curve. Kind of maybe my curve is doing this. You can see the tangent line. The normal line is perpendicular to it. And so, of course, you remember from Algebra 1, to get a perpendicular slope, you just take the opposite reciprocal slope. But you don't have to worry about normal line problems. Unless you're an engineer, you'll be doing the normal line quite a bit in your physics class. Because the normal line tells us something about center of gravity and things like that. So, but normal line is perpendicular to the tangent line. So I like 1 to 43 there, odds in 3.1. In 3.2, Oh my God, it's so slow. I like 1 to, let's say, 49. And in 3.3, and I'll write this down on my screen in a second, okay? So no homework due Monday, but I need you kind of on top of these over the weekend so that you're ready for the chain rule on Monday. Chain rules usually where I lose a couple students. One to 35 is good there. So suggested problems. 3.1, number 1 to 43. 3.2, always odds, right? Because that's what I have answers for you. Even though you're just checking your answers in the back of the book, you should still every now and then check the way you would on a test, right, on Desmos, just to keep yourself sharp on that, right? So anytime they give you a tangent line, yada, yada, yada. Anytime they give you a derivative, right? Yes, you with me? Nice. Let's do a couple problems in 3.3. How about number 12? Cos of x, I'll zoom on it just so you can see it now, but I'm going to write it. Cos of x over 1 minus sine of x. So number 12, and I want to find the derivative, right? No more limits finding derivatives. After this test, no more. Until the final exam, if some of you still can't do it, then it will definitely be on the final. Whatever some of you can't do, it will be on the final. Why? Because I'm cruel? No, because I want you to show me now you get it. So it takes some of us longer. There's nothing wrong with walking out of here and going, what the hell? What the hell was that? What the hell happened? But then you got to figure it out. You got to practice. You got to do some research, do some reading, ask for help, right? All right, here we go. What did I say? 12? So this is 3.3, number 12. So find f prime if f of x equals cos of x over 1 minus sine x. Right? So, quotient rule, right? God, we're doing this a lot today. So if upstairs function is cos of x, the derivative of that is, very good class, negative sine of x. Downstairs function is 1 minus sine x. Derivative of that, well, the derivative of 1 is 0. The derivative of sine x is cos x, and that negative coefficient comes for the ride, so negative cos x. Is that okay with everyone? Question? Yes. Downstairs function is 1 minus sine x. The derivative of 1 is 0, so you can see the 0 here, right? The derivative of sine is cosine, and the coefficients go for the ride. So that negative 1 out front of the sine x just goes along with it. Can't get that erased, that's okay. And then I need the downstairs squared, which most likely I'm not going to do anything with. Maybe, but most likely not. So f prime of x is negative sine x times 1 minus sine x, negative negative cos x times another cos x. over that downstairs squared. So I can't factor anything right now, but let me see what happens if I distribute, right? So what do I get here? I get a negative sine x plus sine squared x plus cos squared x all over 1 minus sine x. So now, the game we're playing here is one of my favorite games from pre-cal, which was your trig identities. Remember how you had to do trig identities in pre-cal? You would have to either go down one side to try and make it look like the other side, or get stuck and then go down the other side and try and make it look, until you got them to match without crossing. And you got your identity verified or proved, or so. Same thing we're doing here, but I can see I've got a sine squared x plus cos squared x, which is 1, right? So I have a 1 minus sine x over 1 minus sine x quantity squared. Cool. So f prime of x is 1 over 1 minus sine x. And you might, yeah, Abigail? Yes, exactly. I could have done that. And that's the thing. The beautiful thing about proving like trig identities is there's more than one way to go, right? She said we could have taken that cos squared and turned it into the Pythagorean identity, 1 minus sine squared, right? And it might have been quicker that way. But we want to make sure we double check it, right? You want to do a tangent line here? What's a good x value? How about 3 pi over 4? So x will be 3 pi over 4. And of course, we know sine and cosine at 3 pi over 4 are plus or minus rad 2 over 2, right? Well, the tangent line won't necessarily help us check. But if we got our derivative wrong, for sure the tangent line will be wonky at that point. It won't be tangent. Right? So we would want to check our derivative here first. Right? So we can do that first, and then we'll get the yeah, exactly. So let's do this together. On Desmos, we're going to use f of x because it will help us check our tangent line. So we had equals cos of x all divided by 1 minus sine of x. So there is our function, looking awfully like a tangent, isn't it? It's actually the negative of a cotangent here, if you see it, but it doesn't matter. Let's plot our derivative, y equals f prime of x. And then let's plot, so that's in black there. And let's plot our derivative we got, which was 1 divided by 1 minus sine x. Nice. Right? I had said I want to put 3 pi over 4 in, right? So let's just see where that is. 3 pi divided by 4, comma, f of 3 pi over 4. Before I even do any algebra, whoops, I've lost my comma. Nice. So I can at least get an idea that I should get a negative for the y value, and I should get a positive for the slope, right? Do you see that? Yep. Everyone okay? Okay. No one is doing this with me on Desmos, but that's fine. I don't care. All right, let's find the y value. So I have to plug that into the original function, cos of 3 pi over 4 over 1 minus sine of 3 pi over 4. So pi over 4 is cut the whole pizza into 8, and of course there's 3 pi over 4 right there, right? So I know sine is positive and cosine is negative, yes? So negative rad 2 over 2 over 1 minus rad 2 over 2. It looks like I'd want to clear with 2 over 2. Do you agree? So I get minus rad 2 over 2 minus rad 2. And most likely I would want to conjugate here just because that's what we did in pre-cal, right? Why waste all that time we spent in pre-cal and not use this stuff? So I get negative 2 rad 2 minus 2 upstairs. And downstairs, what do I get? I get 4 minus 2. So it looks like I get negative rad 2 minus 1 as my y value. Yuck. I don't know who picked this problem to do, but we're not happy with them. It might be easier to factor out that that negative first, just when I'm thinking about when I go to my tangent line. Okay, slope. I have to plug that 3 pi over 4 into my derivative. Right, but we know we get a positive out of that. So 1 over 1 minus rad 2 over 2. Ugh, what horror. Who picked this problem? I don't know. I don't want to finish it. Finish it if you want. I'm going to do another one from the book. Sorry. How about 17? Let's find that derivative and not find a tangent line. So it's quotient rule again, but what's going to happen downstairs? Look at 17, right? When I do the quotient rule, I'm going to have to do a product rule downstairs. So this is a good one to do. Here we go. So f of x is equal to 2x over sine x tan x. Quotient rule. Upstairs function is 2x. What's the derivative? Yep. Downstairs function is sine x tan x. So just a little side work. I'm going to do another loop, right? Of sine x, derivative is cos x. Tan x, derivative is secant squared x. So I'm doing the product rule there. So sine x secant squared x plus cos x tan x. That one does simplify. But let's see what happens if we just go right for our quotient rule, right? So I get 2 sine x tan x minus 2x sine x secant squared x. Cos x tan x is just sine x, right? So it looks clearly like I can factor out a 2 sine x from everything here upstairs. Which is nice because one of my sines cancel there. What is it? Sine squared x plus cos squared x is 1, right? And if I divide everything by if I divide everything by cos squared, I get what? Tan squared plus 1 equals secant squared. Doesn't look like it helps me much. I'm just trying to see if I can finish anything here. But let me write at least what I got here. I got 2 times the tan x minus x sec squared x plus x all over sine x tan x. Oh, sine x tan squared x, right? Can't do much with it. Oh, yes, I can. I can. I can take out a negative x and get secant squared x minus 1. And what's secant squared x minus 1? What is it? Tan x, tan squared, right? So I have 2 times tan x minus x tan squared x. Ha ha! So I can factor out a tan x now. It's just a game. Play the game. So I have 1 minus x tan x over sine x tan squared x, and one of the tangents now cancel, and I look like I have my final answer. So they're like that. Do the thing, do the problem, look at the answer, and decide, oh, I got to do some trig identities here, or I got to factor, or right? Yeah. So we're out of time. Sorry, I'm a little out of time. And I'm sure there's a better way to get there than I did, but practice, practice, practice.
That was for the one like last week. This is for the
That's
second
fine.
paper.
Yes, thank you. What you got?
I did the same thing with that. So like when I was doing this, I just did what we did.
Yeah, that's fine.
Yeah.
So then you see a sign here,
Mhm.
a sign here, and there's, remember, this is a sine over cosine twice, sine squared over cos squared. So you can factor out that sign, and it will cancel with one of the signs here. You have a sine squared here.
Oh, okay.
So just kind of chip away at it and see if you can get it down to that one.
Okay.
Yep. And no, it's not pretty.